Hey guys, today we are going to start our final lesson of the year for chapter one. At the end of this week here, we're going to review some of the concepts that we learned so far this year. And then on Tuesday of next week, we will be taking our chapter one test. So if you're confused on any of the topics we've learned so far, make sure you let me know. So just as a recap, so far this year, we have already learned all of these things. We've learned about greatest common factor, or sometimes we call that GCF. We've learned about least common multiple, sometimes we call that LCM. We've learned about ratios, how to set up ratios, rates and unit rates, and how to look at miles per hour or how much money it's going to cost for a certain amount of items. We've set up ratio tables. We've looked at ratio tables and how to use them. We've graphed ratio tables on a coordinate plane. And then just last week, we started doing equivalent ratios. So looking at a ratio that would be equivalent to another ratio to try to solve problems. So in this final lesson, we are going to kind of combine it all together. So hopefully a lot of this kind of sounds familiar. So let's put it all together. Here's our real world link here. So in this gaming situation, it says an arcade sells game tokens individually or in packages. They're having a sale on token packages as shown below. So if you're looking at the table here, we see that one package is $5, two packages is $10, three packages of coins would be $15. So we're going to use that table for all of the parts of the question here. So if I were to give you a set of questions, not just one question, a set of questions like this, could you use this table over here to answer all of these questions? And I believe that you can. So let's break these down question by question. So question number one says, how many token packages can you buy with $20 and how many token packages can you buy with $25? And it says explain. So if you're looking at the table here, I'm trying to look for a pattern, right? We know that all of these have to be equivalent to each other. So I know that 1 over 5 is equivalent to 2 over 10. And 2 over 10 is equivalent to 3 over 15 because all ratio fractions are going to be equivalent to each other. So if one package equals $5, two packages equal $10, we know that our unit rate is one package for $5. So I'm looking at this and I see a pattern here. I see that every time I start here and go to the right side, I am multiplying by 5. So 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. So I'm trying to figure out what times 5 is going to give me this 20 here. All right, you could even add a couple rows onto the ratio table, which I'm going to show you in a second. But since I know that one package is $5, I know that for $20 I can buy 4 packages because I know that 4 times 5 is 20. And then the same thing for 25. If I know that there's $25 that I have in my hand that I can spend, I know I can buy 5 packages because each package is $5. If you look here, you can even add rows to the table. So if I added 2 more rows to this table, I could have said 4 packages and 5 packages, and then I could have figured out that the price over here would be 20 and 25. So sometimes it might even be easier just to draw the ratio table and keep expanding on it. The second question this table uses, it says, what is the unit price? Like I said, the unit price is always going to bring down one of the numbers in the problem to 1. So they already luckily did that for us. So you see here it says one package is $5. So our unit price is $5 per package, right? So if I wanted to know how much it's going to cost, I know it's $5 per package. I can use that unit rate to decide any of the other ones. So if I wanted to know what the cost of 10 packages is, I can use this $5 per package to figure that out, okay? Next, an arcade game sells tokens individually or packages. It's the same. This is the same table as we've been using. So let's look at a different type of question that we might be asked. How much would it cost to buy 6 token packages? Well, this isn't going to be overly difficult because we're just using the same pattern we just talked about. So if I had set this up like this, I could take the unit rate, $5 per package, and I could set it equal to something, this question mark number, over 6 packages, because the question mark number, we want to figure out how much it's going to cost, right? So I could also look for patterns this way. So I know that to get from 1 to 6, I have to multiply by 6. And I know whatever I do to the bottom here, 1 times 6, I have to do to the top. So if I did 5 times 6 up here, I'm going to get 30. So 5 times 6 is 30, so that means this number up here would be $30. Okay, so you can look at numbers side by side as well. Or I could have just used my unit rate. One package is $5 and multiplied it by 6 that way as well. All right, and the last one, this is probably the toughest question that you might get asked in a table that looks something like this. It might have you compare 2 different rates to see which one's the better rate or to see how much more you could have saved in money. So it says the arcade sells individual tokens. So remember, we've been talking about token packages. They sell individual tokens for 25 cents each. If a token package costs 25 or contains 25 tokens, so one package contains 25 tokens, how much would you save by buying a package of 25 tokens instead of 25 individual tokens? Okay, so we have to think about this because we have to figure out what's going to be the better rate here. So a package of 25 tokens costs $5, right? 25 tokens, $5. However, one individual costs 25 cents. So somebody may be thinking, oh, well, 25 cents might be better. But we have to kind of think about that and figure out if it's going to be better to buy the package or if it's going to be better to buy just the individual tokens. So if one individual token costs 25 cents, that means I can buy 4 tokens for $1. So then if you think about that, 4 tokens for $1, I need to figure out how many dollars I would spend total if I wanted to buy 25 tokens. So I could set this up like this. 4 tokens over $1 is equals 25 tokens over how many dollars is this. So this is going to be a little bit difficult to take 4 times something to get to 25. So I might actually have to divide this out, 25 divided by 4. Or I can just think about money, right? I can think about how many quarters I would need in order to get to 25 tokens. So you can even draw a picture for this. But when you work it out, you would notice that you are going to spend $6.25 if you used individual tokens. So if I bought every token individually and I bought 25 of them, I'm going to spend $6.25. But that's not actually what the question's asking. The question's asking how much would you save if you bought the package of tokens compared to buying them individually. So then all I would have to do is go back up to the top and do 625, which is how much I would spend with individual tokens, minus $5, which is how much I would spend for a package of 25 tokens, and then subtract it, which I would end up with $1.25. So I would save $1.25 if I decided to buy the package instead of buying them all individually. All right, that was kind of a lot, but let's do a couple more examples here. So it says Heritage Middle School has 150 students. 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So we're going to compare the 2 over 3 to the entire school population here. So you can do this a couple different ways. You could actually set up a bar diagram like this method right here. So I know that there's 150 students total in the school, but I know that 2 out of 3 prefer gel. So I know that means 50, 50, and 50 is how I can split up into threes. And I can shade in the first 2 50s because that means 2 out of 3 people prefer gel. This might be a little bit confusing to some of you, but this is a way that you can set up as a bar diagram to figure out how many students prefer gel toothpaste altogether. So if I have 2 out of 3 preferring gel toothpaste, I can see that 50 plus 50 is going to give me 100 that do prefer it. But I think the easier way and the way that I'm probably going to practice more in class is going to be this way, using equivalent fractions, because we just practiced that. So if I know that 2 out of 3 people like gel toothpaste here, I can set it equal to a number, whatever number that is, over 150. Okay. And then again, I just have to look for patterns. So how can I get from that 3 to that 150? Well, I know I can multiply that by 50. So if I multiply that by 50, that means I have to multiply the top by 50. So then 2 times 50 is going to give me 100. So then that shows me 100 students would prefer gel toothpaste. So I think this is the preferred way to use it. But again, if you like drawing pictures, I can help you out with that way as well. Now let's have another one here. The ratio of number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. So that means for every 3 messages Lucas sends, his sister sends 4. Lucas sends 18 text messages now. How many text messages would his sister send? So we're going to compare those two ratios. So again, you could use a bar diagram and set it up this way because for every 3, you see the 3 boxes here, text that Lucas sent, his sister sends 4 texts. And I can split up that number of 18 into 6s and I can find out the answer that way. But again, I want to look at it in this format. So if I was using equivalent ratios, I know that Lucas sends 3 texts, his sister sends 4. And then in the next situation, I know that Lucas is sending 18. So I need to figure out how many his sister is sending. So then we just have to look for our patterns. So how can I get from 3 to 18? Well, I see over here that I can get from 3 to 18 by multiplying by 6. So 3 times 6 is 18. And since I did that to the top, I have to do that to the bottom. So 4 times 6 is 24. So I know that Lucas's sister is now sending 24 text messages if he is sending 18. So that is how we would solve that one. All right, now you try. You can use either method, but I'm going to set up the second method for you just to kind of get you started. So it says, in a survey, 4 out of 5 people prefer creamy over crunchy or chunky peanut butter. I actually prefer creamy over chunky peanut butter myself. Well, there are 120 people shopping at the grocery store. If you took a survey of all those people to predict how many people in the store would prefer creamy peanut butter, what would the answer be? So it says we want to predict how many people in the store are going to prefer creamy peanut butter if our ratio already is 4 out of 5 people preferring it. So here's how you're going to set this up before you work it out. So if I have 4 people out of 5 people preferring creamy peanut butter over chunky peanut butter, how many people out of 120 are going to prefer creamy peanut butter? So look for the patterns here, especially from the bottom, and then do the same thing to the top to figure out our answer. Okay, if you did this correctly, you should have realized that 5 goes into 120 24 times, because 5 times 24 equals 120. So then all I have to do is look at the top number, 4, multiply that by 24 as well to get to 96. So that means 96 people would prefer creamy peanut butter in the store if you would survey them if our ratio is 4 out of 5. All right, let's do one more example together. This one you might have to break down to a unit rate, which I'll explain in just a second. So it says Jeremy drove his motorcycle 120 miles in 3 hours. At this rate, how many miles can he drive in 5 hours? So we're going to set it up. It says at what rate did he drive his motorcycle? So we want to figure out how much he can drive in 5 hours if his rate is 120 over 3. So if I set up the situation like this, 120 miles over 3 hours is what I'm given. I want to figure out how much out of 5 hours, right? Well, I tell you to look for patterns, but I can't really get from 3 to 5 very easily, right? So instead, I'm going to take this first fraction and I'm going to break it down till its unit rate, which means I'm trying to get this bottom number to 1. So if I broke it down to the unit rate, I know that I can divide by 3 out of the top and the bottom. This 3 is going to become a 1 hour, and this 120 is going to become a 40, all right? Because if I take 120 divided by 3, I'm going to get to 40. So that means that 120 miles over 3 hours equals 40 miles over 1 hour, which means that 40 miles per hour is my unit rate. Now, if I take this 40 miles per hour, and then I could find out a lot easier how much you can drive in 5 hours if I have this unit rate instead of this one up here. So then you just have to put them side by side, right? So 40 miles over 1 hour times 5 hours that we want to figure out how much you can drive equals 200 miles total. So if you break it down to a unit rate, sometimes it's easier to work with that second number instead of trying to find a weird pattern in here. So in this situation, Jeremy can drive 200 miles in 5 hours, driving at a rate of 40 miles per hour. All right, this is the final one. This is kind of a STEM related question. I want you to try it. You can do any of the methods that we've talked about today. Just try to figure out how to set this up and then work it out. While resting, a human takes in about 5 liters of air in 30 seconds. At this rate, how many liters of air does he take in during 150 seconds? So set this up. It should look something like this. All right, if you're struggling, this is what your setup should look like at the beginning. So you take in 5 liters in 30 seconds. How many liters am I going to take in? Question mark in 150 seconds. So look for patterns. See what you can do to figure this out. Okay, if you did this correctly, I think the fastest way is to realize that 30 goes into 150 5 times. So 30 times 5 gives me 150. So if I know that, I can take this top number, remember, multiply that by 5 to get me 25. So I know that I take in about 25 liters of air in about 150 seconds based on this ratio here. You could have also broke this down to a unit rate. I could figure it out that this is 1 liter over 6 seconds and figure it out that way as well. So it says, therefore, a human would take in about 25 liters of air in 150 seconds. We're going to practice this a little more tomorrow. Hopefully, you were able to follow this. Make sure you know that you can rewatch any of these sections. And if you have any questions, make sure you get a hold of me and we can work out some problems together today. Have a good, awesome Monday.